Hello everyone, this is Rui PCB, your trusted PCB partner. Today, we will continue introducing the schematic tool in KICB. Following up on the previous episode, let's continue our introduction. This tool is the Place Connection Point tool. It is used to connect two intersecting wires, or a wire and a pin. If there is no connection at the intersection, we need to place a connection point. For example, if we have a wire like this and another wire crosses it like this, in the system these two wires are not actually connected. So if we want them to be connected, we need to use this tool to indicate that these two wires are connected. Actually, there is another way to achieve this as well. When we are drawing wires, we need to select the wiring tool. While drawing, first end the wire at this point on the line, and then draw again, drawing in two segments. This will also create a connection, achieving the same function. The next tool is called Place Local Label. Local labels connect objects located on the same schematic sheet. For connections between two different sheets, you need to use global or hierarchical labels. So let's first create a hierarchical sheet to explain the difference with local labels. This tool is called Draw Hierarchical Sheet, which means drawing a module based on this schematic sheet. Let's name it LED module. This now represents the contents of a new schematic sheet. We can double click to enter this hierarchical sheet, and we will continue to place our connections. Now, let's continue explaining local labels. We'll name this one LED1. Now, with this connection, we have an LED1 in this schematic. If I place another LED1 in the same schematic, connect it to another component, and then place another component, the system will connect this pin, tend to the pin of this LED within the same schematic sheet, making it possible to achieve the connection. If we go back to the upper level schematic and place another LED1, the system will not connect the pins of those two previous LED1s to this new LED1 because they are all local labels and only take effect within the current schematic sheet. So you need to pay attention when using them. Next, the following label is called a net type label. Net type labels can be assigned design rules and are mainly used for PCB and graphical properties, primarily for net grouping in schematics. In KiCad, every net is part of a certain net class. If you don't add a net to a specific net class, it will belong to the default net class. The default net class exists temporarily, so you don't need to create it. For example, if we have this bus and we need to control it to 50 ohm impedance, we can create a net class, label it as 50 ohm, and place it here. This indicates that these lines require impedance control. So if the schematic is not drawn by the same person, or even if it is the designer, might forget which lines need impedance control. Having this label helps prevent forgetting, and when the work is divided among different people, it effectively communicates the necessary information. Next, we have the global label. The purpose of the global label is to correspond to the local label. For example, here I place the LED2 connection on pin 9. Then when we enter this subcircuit, we also place a global label LED2 on pin 9. When designing the PCB, the system will connect pin 9 of both components together. This is what global label does. It can be used across different schematics. Next, this is called a hierarchical label. The purpose of a hierarchical label is to create connections between a subcircuit and its parent circuit. Let's take a look at how to use hierarchical labels. Click on it and we set it to LED 3. So if we need to use this LED 3 in the parent circuit, how should we do it? We can't just place LED 3 directly like a global label that won't connect it. Instead, we need to use the tool to import hierarchical pins from the subcircuit, which is this tool. Click on Import Pins from Subcircuit and you'll see that it displays LED 3. The LED 1 and LED 2 from our previous diagram won't appear here, only pins of this type will be shown. Click Import and now we can see that the subcircuit block in the parent diagram already has the LED 3 pin. It can now serve as a pin for connections, allowing us to connect it to other places and thus achieve cross-diagram connection. The advantage of this is that it allows you to more clearly define the inputs and outputs of the subcircuit, treating the subcircuit as a component or module for use. As for the other tools, such as the component library, package library, tool pins, placing text boxes, drawing circles, drawing rectangles, and so on, which we have already covered before, we won't go into detail about them here. With that, we've finished introducing all the schematic tools. If you enjoyed this video, please subscribe to my channel for more content. Thank you all.